Let me start tonight's show with some dramatic visuals. Imagine a fighter jet so advanced it can dominate enemy airspace, strike deep into hostile territory undetected, and return without a trace. But here is the real question: can a single drone be both a silent assassin and a frontline air combat champion? This is the challenge. Reshaping modern warfare in Pakistan is at the forefront of this revolution. Welcome to the Deep Dive. Today, we uncover Pakistan's next-gen stealth drone technology and the dual-role dilemma of air supremacy versus covert op. Modern drones have a tough balancing act to pull off. They need to avoid radar, which is called low observability or stealth. The answer lies in LPID, low probability of intercept or detection. Imagine hiding a signal in a noisy room. If everyone is talking loudly, your voice might get lost in the chatter. That's the idea behind low probability of intercept: deceive, confuse, and disappear. LPID is a technique used in radar to hide signals by embedding them in background noise. Think of it like trying to find a needle in a haystack. They explored the possibility of integrating Chinese electronic warfare and communication systems into Pakistani drones. Traditional data links send and receive information in a straightforward manner. But LPID introduces a layer of complexity. The drone's signal is transformed and embedded in a way that makes it hard to track. The idea is that the enemy is listening, but they won't be able to make sense of what they're hearing. At the same time, friendly forces can decode the signal and get the information they need. Together, they are working to develop drones that can operate in a wide range of scenarios and perform various missions, including surveillance, reconnaissance, and combat operations. This includes the integration of software-defined radios, which offer greater flexibility and adaptability in terms of frequency bands and communication protocols. These radios can be reprogrammed to operate on different frequencies and communication protocols, making them ideal for use in drones. Electronic warfare involves using electronic means to attack enemy communications and other systems. Turkey and China have both invested heavily in electronic warfare and have developed advanced systems for use in drones. We've discussed the need for stealth and data link flexibility. Let's see how Pakistan is making it happen. This capability could give Pakistan the edge on the battlefield. The Barak UCAV is expected to be a multi-role platform capable of performing various missions such as reconnaissance, surveillance, and strike operations. The drone is designed to have a high payload capacity and a long range, making it suitable for a variety of missions. It showcases the ability of a nation to indigenously design and produce complex systems, reducing reliance on foreign suppliers and potentially lowering costs associated with purchasing foreign military equipment. Moreover, it stimulates economic growth by creating jobs and fostering innovation in the local industry. Pakistan, too, has recognized the importance of electronic warfare and has been working to improve its capabilities. These initiatives are not only focused on creating advanced drones, but also on developing the necessary infrastructure and expertise to support their development and production. The goal is to create a thriving domestic UAV industry that can meet the growing demand for unmanned systems in both military and commercial applications. It needs ultra-fast, high bandwidth links for OODA-loop dominance, observe, orient, decide, act. It's a fascinating world of technology where stealth meets connectivity. If you enjoyed this episode, don't forget to give us a thumbs up and subscribe for more deep dives into the world of defense tech. And if you have any thoughts, comments, or suggestions, drop them below. We would love to hear from you. Thanks for joining me. Until next time, this is your host, signing off. Stay curious and keep exploring the frontiers of technology. The challenge is switching from whisper to shout without tipping off the enemy. The real breakthrough, knowing when to vanish and when to strike. With Turkey and China as allies, Pakistan's stealth tech could redefine regional power. Turkey has been working on developing its own SDRs and has made significant progress in recent years. China, on the other hand, is already a major producer of SDRs and has supplied them to various countries around the world. AI algorithms play a crucial role in LPID by analyzing vast amounts of data and identifying patterns that humans might miss. These radios use machine learning algorithms to analyze the radio frequency environment and select the best frequencies and modulation techniques to use. This allows them to exploit the gaps in the enemy's detection capabilities, making it harder for them to be detected. They can also adapt to changes in the environment and make real-time decisions based on the latest information available. For example, an AI-powered system could analyze changes in the enemy's detection patterns and adjust the drone's signal accordingly, making it harder to track. These collaborative efforts aim to enhance the stealth capabilities of Pakistani drones and provide them with advanced communication systems that can operate in a wide range of scenarios, including air-to-air and air-to-surface operations. China, on the other hand, is already a major player in the drone industry and has developed advanced electronic warfare and communication systems for drones. The collaboration between Pakistan, Turkey, and China is leveraging the strengths of each country to develop advanced drone technologies. This approach reduces the likelihood of detection by making the signal very difficult to track. But they also need real-time data links for air combat. That means modern drones need to be smart about what data they send and when they send it. Well, modern drones are equipped with sophisticated data links that enable them to communicate with each other and with ground stations in real time. These advanced systems can automatically adapt to changes in the environment and change the way they transmit signals. They can also analyze the surrounding radio frequency environment and select the best frequencies and modulation techniques to use. This allows the drones to exploit the gaps in the enemy's detection capabilities, making it harder for them to be tracked. However, these data links are also a potential source of vulnerability. An enemy can intercept these signals and determine the location of the drone. This is where LPID comes in. By embedding the drone's signal in a way that makes it hard to detect, drones can stay hidden and strike with precision, but constant communication to get that real-time data link for air combat could tip off the enemy. Pakistan is grappling with this dilemma, trying to build a drone that is invisible during covert operations but hyper-connected during For instance, by rapidly switching frequencies or changing the way signals are encoded, drones can throw off enemy tracking attempts. Recently, Pakistani and Turkish officials gathered to discuss joint ventures in the field of unmanned aerial vehicles. One of the key areas of focus was the development of conformal antennas for stealth drones. Conformal antennas are designed to fit the shape of an aircraft, minimizing any radar reflections and providing better coverage. The collaboration between Pakistan and Turkey aims to develop conformal antennas that can operate in the LPID mode, further enhancing the stealth capabilities of Pakistani drones. The idea is to become invisible to the enemy's detection systems. It's a balancing act that could change the face of modern warfare. Some data can wait, but sending critical information quickly can mean the difference between life and death. So modern drones need to decide what to send and when to send it. And this is where the real challenge lies. They provide real-time data, control, and sometimes even weapons guidance, but those same data links can betray a drone's position, turning it into a sitting duck. As we know, information warfare is raging. Many modern conflicts are being won or lost based on who has the edge in information superiority. Data links make it possible for drones to share critical information like enemy positions, but they also make them vulnerable to detection. In today's battle space, winning a fight often depends on who sees first and acts first. Stealth is only useful if your data link is glowing like a flashing Christmas tree on enemy radar. In the world of drones, stealth goes beyond physical design. It extends to the signals they emit. In modern warfare, stealth is no longer about avoiding radar. It's about deceiving it. Today's drones can carry heavy payloads, fly long distances, and stay in the air for hours, all while evading detection. But once they enter a combat zone, the game changes. The real challenge lies in their data links, the lifeline between drone and operator or between multiple drones in a swarm. So, how can a drone be both a ghost and a warrior? But how does this apply to modern drones? To achieve this, Pakistan is turning to AI-driven cognitive radios. The goal is to create a system that can process and react faster than the enemy, making it extremely difficult to detect. Pakistan is not going it alone. It has joined hands with Turkey and China to develop advanced communication systems for drones. Another significant development came with a visit from Chinese experts. So, How will these technologies work together to make drones more stealthy? Well, it starts with a data link. This brings us to the role of artificial intelligence or AI. AI is also essential for developing cognitive radios, which are at the heart of LPID technology. And that's where Turkey and China come in. Turkey has been working on developing its own UCAVs and has made significant progress in recent years. Pakistan brings the expertise in aviation and drone development, while Turkey and China bring their advanced technologies and know-how in electronics and software. One of the key areas of collaboration is the development of software-defined radios or SDRs. Another area of collaboration is in the field of electronic warfare. The collaboration between these three countries is expected to result in the development of drones with advanced electronic warfare capabilities, allowing them to operate in contested airspace and perform a variety of missions. Now, let's talk about two missions. One drone. In covert ops mode, the drone whispers. It uses slow, encrypted signals, prioritizing stealth over speed. In air combat mode, the drone shouts. Enter Project AZI, and Pakistan's ambitious UCAV program aims to fuel drones that can switch roles dynamically. A silent hunter today, an aerial predator tomorrow. There's also the Barak UCAV, another project aimed at developing unmanned combat air vehicles. Pakistan's efforts in developing its own UAVs demonstrate its commitment to advancing its defense capabilities. The development of indigenous UAVs is a sign of technological advancement and self-reliance. The future is dynamic. Covert ops, or air combat, Pakistan is making the switch possible. Well, there you have it, folks. We've delved deep into Pakistan's next-gen stealth drones, the silent killers and air